Hi there. Good morning, good afternoon, good evening, wherever you are. This is Arun Gupta, and I work for Red Hat as Director of Developer Advocacy. And today I'm very excited to spend the next few minutes, actually in about an hour, talking about Java EE 7. So let's get started then. Now, Java, we know is the most adopted platform on this planet. In terms of, we always boast of 9 million Java developers actually. So with 9 million Java developers, lots of them are building their applications on enterprise Java, which is where Java EE fits in very well. And if you're building your applications to Java EE, then the beauty of that is, you build your applications using Java EE API, and you have a lot of variety in terms of open source application servers or commercial application servers as and when you can deploy to them. Java EE 6, as a matter of fact, saw the best adoption for the Java EE platform. Not just from the customers, but even from the vendors. So for example, today, there are 18 compliant Java EE 6 application servers, which is very compelling. So you can see there's a good variety of open source application servers. So name it either GlassFish or JBoss AS7 or Wildfly, which is coming up soon, or Caucho. There are some lightweight vendors, or there are full-blown commercial application servers as well, such as JBoss EAP or WebLogic and others. Okay. Now, Java EE 7 platform itself was released in June of last year. While I was at Oracle, I actually led that launch in terms of the webinar launch. It was a fun exercise, working with everybody in the community, highlighting all the work that we were doing for over past 3 years or so. So it was a long time in the making, but I think this was one of the most successful launches at Oracle and in terms of the community and technology as well. So today I'm very excited that I will be sharing the details of the platform with you and showing you tips on how you can get started with it. Not only that, but I will be providing you specific areas where I need your help. We want to make the platform to be very successful. Java EE 7 had 3 big themes: developer productivity, HTML5, and meeting enterprise demands. Now, developer productivity was sort of kick-started around Java EE 5 timeframe. That's the first time when we said, okay, let's focus on POJO-based development, start adding annotations, pick it up from JDK 5, and kind of start making deployment descriptors, a little bit, I think, of the past. And then Java EE 6, again, took that to the next level. And Java EE 7, we literally took it to an extreme level where we said, okay, heavy focus on POJO-based development, deployment descriptors really becoming optional in that sense. In Java EE 6, we also introduced CDI, so context and dependency injection. Now that saw a lot of improvement in the platform to the extent that we said we're going to make it an inherent part of the platform itself. And that in turn gave us a very integrated, cohesive platform. So that's about the first theme. Now, HTML5 has been kind of becoming more prevalent over the past couple of years. There are several things associated with HTML5, name it WebSocket, JSON, REST, CSS3, and all those things. And all of those are very well supported in the Java EE 7 platform. So now there is support for there's first-class support for WebSocket-driven applications. There's native support for JSON parsing in there. REST server API or client API both exist. You can even build your applications highly scalable. And something that Java EE in general has been very, very good at is meeting your enterprise demands. However, a couple of features were missing from the platform up until now, and those have now been integrated into the platform. Most importantly, there is ability to do batch applications. And now you can actually do your own threads, which are actually managed by the server runtime. So that's pretty cool. And then JMS was long due for an overhaul, and we updated that as well. So in this presentation, I will walk you through each of these technologies and see what has been changed in them. Now, in a very classic David Letterman style, I'll give you my top 10 features in Java EE 7, and instead of starting with 10, 9, 8, 7, I'm going to go with bang on, first, 2, 3, 4, like that. So WebSocket, by all means, to me, is the most important technology that was added in Java EE 7 platform. Now, you can take a Pojo, put an annotation on it, and that becomes your WebSocket endpoint. No deployment descriptors, very clean, very simple. You can not only deploy just server endpoints, but even client endpoints, and we'll take a look at that. What does that mean? First-class support for batch applications. You no longer have to rely upon third-party like Spring Batch and technologies like that. Now there's support in the Java EE 7 platform itself. There is support for JSON processing, as I said. So again, you don't have to rely upon third-party libraries. You just take the JSON processing support, which is in the platform, which kind of makes your application lightweight now, without bundling any third-party libraries. And then the concurrency utilities is where you can spin up your own user threads that are managed by the container runtime. Now, if you think about the first 4 items here, those are the new technologies that were added to the platform. So that's the reason they kind of got the first 4 spots. But that's not just all we added in the platform. There were a lot of components that were updated heavily. So, for example, JMS, as I said, was due for an overhaul. The API was extremely simplified, and I'll talk about that, what that means really. For folks who are doing transactional or container-managed transactions, that was only possible in EJB, but now that's possible in a Pojo environment. So you can take a Pojo, put a add transactional annotation on it, then put add transaction scope on a bean, and then you tie the lifecycle of a bean to a transaction. And we'll talk about that as well. JAX-RS primarily has been server-side API, but now we have the ability to do a client-side API as well. We'll talk about that. If you're building a Java EE application, then the understanding is you likely would have some sort of messaging, some sort of database, and things like that. Now, if you want to do JMS, then you need a connection factory. If you want to do database, then you need a JDBC connection or data source. Now, typically those resources are created in a deployment or an application server specific way. But by adding default resources, that means a default data source or a default JMS connection factory, you don't have to create those in an application server specific way. And even there are annotations by which you can add, you can ask the application server to create these properties for you at deployment time. I always talked about more annotated Pojos, so definitely there's a lot more emphasis on Pojos. And then in JSF, we added this feature called as Faces flow, which kind of simplifies how a bunch of related pages could be packaged, bundled, and reused. All right, so let's get started then. The very first one is Java API for WebSocket. Now, each technology in the Java EE 7 platform is released under a separate JSR. So, for example, JSR 356 is what defines how Java API for WebSocket will do. Now, as part of this Java API for WebSocket, what we define is a way by which you can define a server endpoint and a client endpoint. Now, if you understand WebSocket, it provides a bidirectional full duplex communication channel over a single TCP. So the idea is you have an existing HTTP channel, you can upgrade that to a WebSocket, and then you can have unlimited bidirectional communication over that between client and server. Now, in order for that HTTP upgrade to happen, you need to have a server endpoint, and that's what is identified by your add server endpoint annotation. And in order for the client to listen to requests from server, you need to have a client endpoint. That's where you need the add client endpoint annotation. Not just annotated, but even programmatic. So you can create those client and server endpoints in both annotated and programmatic way. There are lifecycle methods introduced as well, annotations rather. So you can take a business method in your Pojo and annotate it with at on open, at on close, and those methods are called, which kind of helps you manage the lifecycle of a WebSocket endpoint. And in terms of packaging and deployment, it's a very standard model. We're not introducing anything new in the JSR. The idea is, okay, let's take the existing Java EE packaging. So you take a Java class, annotate it, and put it in a WAR file, and there you go. That's it. That becomes a WebSocket endpoint. So let's look at the code, which is on the bottom right part of the screen. There's a public class chat server here, and in the chat server, you can see, for example, I'm saying add server endpoint, and then I have a business method which says public void chat. So if I put add on message annotation on this, then all that means is, hey, anytime this WebSocket endpoint, which is a server endpoint, I receive a message, I am going to invoke this business method. Very simple. Okay, so let's look a little bit more. A little bit more detailed source code here. So for example, here I'm saying I have a chat bean, which is a server endpoint, and listening at the URI specified as a value parameter. Now, talking about lifecycle callback, I have add on open and add on close. These are the methods that are being called when the WebSocket connection is being opened or closed with this endpoint. And in these methods, all I'm doing is I'm maintaining a set of session, session being the client or the other end of the communication, which is connecting with this endpoint. So I'm just maintaining a set of active clients over here. In order to make this as a fully functional, simple but fully functional chat server, I just need to add this one method over here. And that one method, is going to be tagged with add on message, saying that anytime a client sends a message, iterate over the list of existing connected clients and send a message back to them. That's it. So just a very simple canonical chat server, fully functional, just in one class. Let's look at another API, Java API for JSON processing. This is JSR 353. Now, if you go by the XML analogy in the Java land, there is a JAX-P, Java API for XML processing, and JAX-B, or Java API for XML binding. JAX-P provides a lower level API where you can process XML at a raw layer. JAX-B, however, is a higher level API where you can take an XML or take a POJO, put an annotation on it, and that will take care of Java to XML conversion and vice versa for you, or JAX-B runtime will take care of it. Now this API is more closely tied to JAX-P. So what it does is it provides a lower level API for you where you can take a look at the raw JSON structure and you can play around with it. And similarly, just like in JAX-P, you have streaming API and a DOM API. Here you have a streaming API and an object model API. So in the streaming API, what you do is you look at the JSON structure and you say, tell me what events are being generated, and you tap into the specific event. So for example, you are interested only in the event that when a JSON array is starting, then you just take care of that and you ignore all other elements. And the object model API is a higher level API built on top of the streaming API, where you can take the entire JSON structure, read the entire thing in the memory, and then index the way you want to do it. Code is always easier to understand than looking at the slides. So here we go. I have a JSON structure or a JSON fragment shown on top of the slide. So it says my first name is John, last name is Smith, age is 25. I have a phone number, a couple of phone numbers, one home, one fax. Now, if I were to read this element or this fragment, using JSON parser, I'll say JSON.createParser, and then I will say, okay, give me the next event. Well, the first event for me is start object, which is literally right after the curly parenthesis, the very first curly parenthesis. Then I say next, then it goes right after first name or the key name first name. Then I say parser.next, then it goes right after John. And at that point when I say, okay, you know what, hey, I like this event, or I want to do something about this event, then you actually say, get me the string, and then gives you the value of string. That's it. So it's very simple in that sense. Another new addition to the Java E7 platform is batch applications for the Java platform. Now, these batch applications are typically very useful if you are running them in a non-interactive way and they're bulk-oriented, and typically long-running tasks. So, for example, think about you're running a bank, and every second week or every end of the month, you need to process bank statements, or you need to generate monthly statements. You may not want to do that during your peak business hours, like Tuesday morning, 11 o'clock, or even during 4 o'clock when the bank is closing, for example. So what you want to do instead is, you want to trigger these jobs like Sunday morning 2 a.m. or Saturday midnight or things like that, so that you just set up the process and the job triggers, it kind of processes through all the accounts and does the whole thing by itself. Now, if you have thousands of records or millions of records, then you may want to think about how to optimize it, whether you want to do the job sequentially or parallelly. What if the job breaks? So there are all these different aspects that you need to be aware of and make a decision accordingly. All of those are supported in the batch applications for Java platform. Now, in the JSR itself, which is, by the way, JSR 352, it defines there are two processing styles. There is a chunked processing style, which is item-oriented processing style, where you take an item, process an item, and write an item. And then there is a task-oriented processing style called as batchlet, which is like doing an ad hoc task. The chunked processing style is the primary processing style, and we'll talk about that. And the way it works is there is a job repository where all the jobs are stored effectively, which is sort of all the metadata for jobs. A job operator, which manages all the batch processes, says, okay, you know what, I'm going to pick a particular job. Once you pick a job, then that becomes sort of your batch process. A job could have multiple steps. These are independent sequential phase of a job. You could have one step, more step, multiple steps. You could make them run sequentially, parallelly, split them, or create a flow around them. So full workflow, I wouldn't say comprehensive workflow, but still pretty detailed workflow support is available in there. But in a step, if we talk about the chunk concept, there is an item reader, processor, and writer. These three work together to execute a chunk. And how does it work? Let's take a look at that. So first of all, my job needs to be specified as using a job specification language. In JSR 352, this is specified as XML. So you have a job XML. So job specification language and job XML are synonymous in that sense in JSR 352. A job has a step, as I said, and a step has a chunk. And in this chunk, I have a reader, processor, and writer. The ref field actually refers to the CDI beans that are packaged in the archive. So if I take a look at my reader implements a method called as read item. And in there, I might have an account using JPA. Then I have my item processor. The same account that I just read is available to me in my process items method that is coming from my implements item processor interface. I may read an account and return a statement. The key part to understand here is the inbound object, which is the account, and the outbound object, which is a statement, could be completely different. So you are taking maybe a POJO and converting it into a JPA entity, which effectively could be given to item writer, or rather aggregated with the writer and written out. Now for every read, if you are writing, that may not be efficient. So what you may want to do is, or what is recommended is, you take an item, you process it, and you give it to the writer for aggregation. And once you have reached the item count, which is what is defined in our job XML as well. So if you look in the top left, there's item count equals 3. So in this case, an item would be read, processed, and written. Or actually, item would be read, processed, and aggregated. Once it's done 3 of those, then it will write it out. And that item count is completely driven by your application effectively. All right, so let's talk about another new component in the Java EE 7 platform, which is concurrency utilities for Java EE 1.0. And this is JSR 236. Now, classically in the Java EE platform, it is not recommended and not even allowed in certain cases to spin up your own threads. The reason being because Java EE is a managed environment, and a managed environment, if you spin up your user threads, what does it mean? How does the class loading context or a GIND context or security context, all of those are passed over to this user thread? And who's responsible for managing these threads? What if the application dies? Do the user threads keep running? So there's a lot of uncertainties around it. So this particular JSR actually provides asynchronous capabilities to Java EE components. And the way it does that is it basically builds upon JSR 166Y, which adds the concurrency support to JDK itself, or Java SE platform. Now, JSR 166Y added executor service, schedule executor service, thread factory, and similar objects to allow you to spin up threads in a neat way. This particular JSR provides a managed version of those. So for example, you could say, hey, I have a managed executor service. You can configure it the way you like it. For example, you can configure it for, say, 10 thread pool, and then the container is responsible for making sure those 10 threads are created and passed over to the user application. Okay? And the best part, which I was saying earlier, is now you have your all the context, class loading, security, GIND, they're propagated to these user threads as well, or user threads managed by the containers. That's how you want to understand it. However, the transaction context is not propagated, because managing transactions across multiple threads is a very tricky problem. So let's look at the code again. So in this case, I just have a simple servlet, and from the servlet, all I want to do is I want to I'm going to inject a resource called as manage executor service. And when I inject the resource, I'm again leveraging something called as a default managed executor service. In addition to the default data source and the default JMS connection factory, which we talked about earlier, we also have a default managed executor service. So there is no need to create anything of your own. I mean, if you want, you can, but there is something to get you started very easily. So you just have a default managed executor service, which gives you a managed executor service, injects it for you, and then you're using your standard design patterns from the Java SE platform. You can just say, hey, I want to submit a task which is a runnable. Now this is running in a container managed thread now. So all those 4 components that we talked about so far are brand new components to the Java EE 7 platform. Now I'm going to talk about how some of the existing components have updated or changed to catch up with primarily with the platform and based upon the community feedback as well. Now JMS, as I said, was last updated over 10 years ago. It was definitely due for a long overhaul, and finally it got that. And I'll show you the code for this, what it takes to write, what it takes to send a simple message using JMS 1.1. But effectively, it's a lot of boilerplate code. There is no dependency injection. Or think about it. When JMS 1.1 was done, this was around the time frame of JDK 4. There were no annotations. Forget about dependency injection. None of that concepts were there. So all of those are now introduced in JMS 2.0. And the way they're being done is, for example, there is a new JMS context interface being introduced that encapsulates the producer and consumer, first of all. Some of the existing interfaces are made auto-closable, so you can use them with try with resources. There is a heavy usage of runtime exceptions, it kind of makes your code look cleaner. Because most of the time, if you catch an exception, you anyway just rethrow it, wrapping it into something else. There is a method chaining, that gives you a fluent API on JMS itself, and a lot more simplified message sending. So let's kind of look at some of the code and get more meaning out of it. This is all the code. Well, this is just the code that you need to send a message using JMS 1.1. If you try to read the code, it will be tricky, but let me kind of highlight 3 issues with the code so far. There is You have to create some application server specific components, which is connection factory and destination. Then you have to honor the API, so a lot of boilerplate code. And then eventually you have to do some exception handling. So this is about 25 lines of code just to send a simple message. If you were to inherit this code to somebody else, it's going to be a lot of work for them to maintain it. They would need to understand the code. If it's a young developer, if it's a college guy, he would be kind of scared to Java. Like, oh no, I'm never going to look back at Java if you give him this code. Now let's take a look at it. What have we done in JMS 2.0? This is all it takes to send a message using JMS 2.0 simplified API. The older API is called as the classic API. The newer API is called as the simplified API. So all we do is we just inject a JMS context here. We're not specifying any connection factory because we're leveraging on the default connection factory. Then we inject a destination. Now this destination itself does not need to be created in the application server specific way. There are annotations which allows you to create this at deployment time itself. And then finally, if you look at the send message method, which is the method that my business logic is encapsulated, from the context, I'm creating a producer, then I'm sending a message to my destination. That's it. If you give this code to a college guy, there is a likelihood that he would be attracted to Java and more importantly to Java E7. Say, oh, this is cool. I can understand this code. This looks more like English. It's not a different language to me altogether. So this definitely improves the semantic readability of your code. So that's sort of what gets me excited about this. Let's talk a little bit about JAX, Java API for RESTful web services. This is JSR 339. And by the way, JMS 2.0 was JSR 343. Now, JAX-RS 1.1, when it was introduced in Java E6 platform, was primarily focused, well, actually only focused on creating a server-side API. So you could take a POJO. On a POJO, you could create a REST endpoint easily by putting annotations. But that was only server-side. So there were a lot of implementations of JAX-RS, but they were again using their own versions of client API. And before JAX-RS 2.0, if you have to invoke a JAX-RS or a REST endpoint, you have to kind of use HTTP URL connection to do all that magic by yourself. And believe me, it is literally magic when I started writing that code. So here in this case, now JAX-RS provides a simplified client API, and I'll show you a sample code for that. In addition to the client API, it's also added message filters and entity interceptors that allows you to easily address your cross-cutting concerns. So you have a client and a server, so two components, and then you have a request and a response on each side. That makes it 4. So you can have your filters and entity interceptors be extension points at any of those 4 points. And the idea is filters are primarily meant for headers, and entity interceptors on the other side are targeted towards when the binding to an entity needs to happen. So you can have these extension points and address your cross-cutting concerns like logging or auditing or gzipping or security, where you don't want the business logic to be exposed. Another concept added to JAX-RS 2.0 is the asynchronous processing of server and client. Again, we are leveraging very standard concepts here, suspend and resume design patterns, but the API has the ability to make the client asynchronous and the server asynchronous. And we've added some common configuration elements to JAX-RS 2.0 as well. Now let's take a look at this code. This talks about how a simple client API would look like. So here, for example, I have a client builder. In the client builder, I'm saying, okay, show me the client that exists. Then once I have the client instance, on the client, I could say, okay, I'm going to set up a target. That target is the URI, which is going to be the REST endpoint URI. And notice in this URI, I have order ID specified in the curly parentheses. That means that is the variable part of the URI, so I can resolve it using resolve template. I can even specify query parameters, which is the value that goes after question mark. Like say if you say URI question mark name equals value, that is what query parameters are. eventually I build a request and I want to invoke a get on it, and that's it. So comes out very well. Now here I'm showing get, but you can do put, post, delete, all of the standard HTTP verbs. CDI. Now context and dependency injection was a new addition to the Java EE6 platform. It was such a fundamental change to the platform that in Java EE6 we didn't realize that, so it had to be explicitly enabled. And the way explicit enabling was done by adding a beans.xml. But after we realized it's such a fundamental change to the platform, we realized, you know what, we don't need a beans.xml. So we enabled CDI by default itself. So for example, in Java EE7, CDI is enabled by default. Now, it is not enabled by default for all the beans. It's only enabled for beans which have a scope annotation. Now, CDI defines a bunch of scopes, which is request scope or session scope or application scope. If you have a bean which has an explicit scope on it, those beans are available for injection by default. That is when you don't have a beans.xml. However, if you do have a beans.xml, then in that you have something called as a bean discovery mode. In that bean discovery mode, you can specify 3 different types: all, annotated, and none. Well, none is a simple one. None is like one faucet turned off and dependency injection is completely gone from your app. Annotated is the default, is the one that I talked about, where any bean which is annotated with a CDI scope annotation is available for injection. And all is where you say, you know what, I don't care about the annotations, all the POJOs are available for injection. That's what it is. Vetoed is another simple addition to the CDI programming language. Here what we're saying is you add this annotation on any POJO and you can programmatically disable bean injection. We also added some support for global enabling ordering of interceptors and decorators. So there are new priorities that have been defined by which these interceptors and decorators could be enabled and disabled. Bean validation was again a new addition to the Java EE6 platform, but at that point of time, the focus was really primarily on, first of all, bean validation is a mechanism by which you can specify constraints on a bean, and those constraints are honored at runtime. Now, if you do that for any POJO, that won't work in Java EE6. In Java EE6, the focus was primarily on JSF and JPA. So think about a JPA bean with bean validation constraint, and if you try to persist, delete, or update that entity, that means it would automatically honor those constraints, and if those constraints are not met, it will throw a constraint violation exception. In Java EE7, that entire concept has been broadened, wherein this concept of a constraint can be applied to any POJO, for example, and particularly it's very relevant for JAX-RS. And that's what we call as programming by contract. So let's take a look at it. Here I have just 2 business methods, place order and get appointment. And on the place order methods, on the parameters, I've specified, for example, multiple constraints. I could say, I don't want the product name to be null. I don't want the quantity to be null. I want the quantity not to exceed 10. And then the customer is something that I have is my custom constraint. Now, at not null, at max, those are constraints predefined by the bean validation specification, but it also defines a mechanism by which you can build upon that constraints and define your own constraints. That's what my add customer is. So it's a custom constraint in that sense. Ooh, the animation doesn't look good. It's kind of getting into my constraints. Now, in the get appointment method, so not just parameters, but in get appointment, for example, I could specify at future, which is again a built-in constraint. So what happens is if I invoke this method, I expect the date to come sometime in future. Now, in either case, if you invoke the business method like get order or place order or get appointment, in either case, if the constraints are not met, it's as if the method was never invoked. It actually instead throws a constraint violation exception. That's what we call as programming by contract. So the contract is not honored, program doesn't go through. Java Persistence API is probably one of the oldest APIs in the Java EE platform. There were still significant additions made to the JPA. This was JSR 338. One of the things about JPA is you can take a database table. From the database table, you can easily create a JPA entity from it. There are standard rules and mechanisms defined for that. What was not available is how you could take a JPA entity and generate database tables from that. That's exactly what is being added in JPA 2.1. So you could take a JPA entity, and then you can specify these called as schema generation properties, which is in the domain JavaX persistence schema generation. And if you specify those properties, using those properties, based upon what the values are specified, you could generate the database table. You can say, you know what, do not generate the database table, just generate the SQL scripts so that I can fine-tune the SQL scripts and then generate the database tables myself. Not only that, but you can say, you know what, don't worry about the entities, just generate or just pick up the SQL scripts that are bundled with my application and then generate the database tables based upon that. So all sorts of possible combinations are available. Not only that, but you can also say, okay, so you have generated the database tables. Now take this DML or data manipulation language, which is again a SQL file. Take this SQL file and load my database tables from this SQL file. So full support for table generation, table manipulation is available. Now one use case that is very handy in this case is which allows you to bridge the engineering team and the DBA team, for example, is let's say you are good at writing JPA models. So you build your JPA model. From the JPA model, you generate your SQL scripts, you give it to your DBA team, they fine-tune it, they give it back to you, then you bundle it in your application. The important part over here is, this is very useful in a cloud environment. So in your WAR file, you can bundle the DDL, DML, all of that, and then you deploy your application on a cloud environment, say OpenShift. So you go to openshift.com, you open up an account, you build a Java EE7 application over there, you deploy a WAR file, then because it's Java EE7 compliant application server, it will automatically create the database tables for you by reading those files. So this is a very useful feature to be used for Java EE7 applications in the cloud environment. Now by default, the persistence context, which is what manages the entity state in JPA, is synchronized. That means anytime and every time you write to it and the transaction is committed, it just writes the values to the data store. With JPA 2.1, we have introduced the unsynchronized persistence context. So you can manipulate the persistence context, so to say, in an offline way. And when you are ready, then you can join the transaction. This is kind of useful, specifically in a disconnected devices scenario. Another new addition done to JPA 2.0 was criteria API. So the JPQL, or Java Persistence Query Language, is string-based text query language. With JPA 2.1, or actually in JPA 2, we added a type-safe query language, but that was only for reading values. Now, here in JPA 2.1, they've added support for update and delete. The JPA 2.1 has also added support for user-defined functions in the database and stored procedures. Servlet 3.1, yet again, one of the most mature technologies of Java EE7. Few additions made over there. So for example, traditionally the way you do input-output in a servlet is blocking. In the sense, you read from a servlet input stream, you block until the client has closed the connection or so, and then you act upon it. Or you want to write, keep writing till you're done. So I'll show an example of this. Hopefully it'll be more clear that way. So I think that will be more clear. The other feature that we added to Servlet 3.1 is the ability to do protocol upgrade. Now, as we talked about in the beginning, WebSockets, the way they operate is by upgrading an existing HTTP connection to a WebSocket connection. and that is a protocol upgrade. So with Servlet 3.1, we have added a standard API by which you can do a protocol upgrade. Not just from HTTP to WebSocket, that's how we are using it, but effectively anyway. And there are lots of innovative usage of protocol upgrades. So if you're interested, for example, Wildfly uses this HTTP protocol upgrade for how you can do your if you send a management request to a Wildfly application server, it automatically upgrades it and it will reduce the number of ports that are exposed to you. Another security enhancement that was done in Servlet 3.1 is if you take a look at web.xml and if you expose a business method over there, or rather if you protect a business method, say get business method or post business method, if you protect one business method, then all other business methods are exposed. So let's say you protected get, but then post, put, delete can be explicitly invoked without any security constraint. And that's a security hazard. So now in this case, what we have done is we have added an element, a top-level element in WebXML, which could be, say, deny uncovered HTTP methods. If you add that element, that means by default, all HTTP methods will be denied, even if you expose one, so, which is a good feature. So talk about the non-blocking I/O. Here is how I would do non-blocking I/O or a blocking I/O effectively. So I have a servlet. In my servlet, I have a doGet method, and I'm reading from a servlet input stream. I keep reading till I get -1. This -1 could be for many reasons, timeout or client closing the stream or error or whatever it is, okay? But what if the client is genuinely doesn't want to close the stream, but it is sending some sporadic data, okay? So in order to support that use case, for an asynchronous servlet, first of all, this is only supported in asynchronous servlet. So what you do is you get the async context. On the async context, you get the servlet input stream, which is standard. But then on the input stream, you set the read listener. And this is a new API. And read listener is the one, if we take a look at it. Read listener has a method called as onDataAvailable. That is a method that is being called whenever there is data available. So there is nothing rocket science here, but it's a very simple suspend and resume design pattern. So you are in an async servlet, you receive data, onDataAvailable method is called. If onDataAvailable method once it's called, it kind of goes back into async mode. Method, more data is being received from the client. Again, this method is being called. And similar concept can be done for onDataWrite as well, or servlet write. In JSF 2.2, there were a few features added as well. Faces flow allows you to package and bundle your related pages together. There was no standard mechanism by which it was by which you could do that today in your applications, but JSF 2.2 exactly defines that. Typically, users have bundled or created their own configurations by which they will bundle up and package up all these things. But now with the standard mechanism, it makes your application a lot more portable. Resource library contracts kind of takes your facelets or XHTML, CSS to the next level, where now you can bundle up your look and feel in a jar file and make it shareable across your different applications. HTML5, when the HTML5 elements were introduced, they introduced some new elements called as type elements. So for example, on a text box, you could say type is color, or you can say type is email or type is number and things like that. Or on any HTML element, you can introduce data store attributes. So with the data store attributes, you could specify certain values and access those values in a JavaScript element. Now, with JSF, if you specify any random attribute on a JSF tag, say h:\input box, it won't be rendered correctly because it needs to be supported by the corresponding backing element, the UI component element, and the render kit. So now what we're saying is, hey, just pass it as a simple as a pass-through attribute. That means JSF, don't try to render it. Just pass the element as is, and the user agent, which is the browser, will try to render it correctly. That's just a way by which JSF supports HTML5 friendly markup. And there were some other updates added to JSF, particularly the new file upload component is worth noticing. The last technology that I'm going to cover today as part of Java EE 7 is Java Transaction API. For the folks who really want container managed transaction outside of Java EE or outside of EJB container, this is exactly what it is being referring to. So you could take a POJO, put an add transactional annotation on it, or take a POJO, say let's have 5 methods, and you want only 2 methods to be transactional, you can put add transaction on only those 2 methods. So depending upon the scope, that method or that POJO becomes transactional. Now transactional is a CDI interceptor binding, by the way, but it is automatically implemented by the Java EE 7 runtime. And just like there are lots of other scopes in CDI, there is a transaction scope that is being introduced, which ties the life cycle of a bean to an active JTA transaction. Now this is what I call as the pancake diagram for Java EE 7. And as you can see, there are 4 new technologies which we talked about extensively, but not extensively, but at least some detail. Then there are JAX-RS 2.0, Servlet 3.1, JMS 2.0, bean validation, which we talked about as well. Now in terms of, well, we learned about the Java EE 7 technology itself. Now where do we try out these technologies? So there are 2 options today. First is GlassFish, which is a reference implementation for Java EE 7. And then second is Wildfly. Now Wildfly is what used to be JBoss application server. It's been renamed to Wildfly, and it's freaking fast. So I just want to highly recommend that. Well, of course I work for Red Hat. Now there are lots of Java EE 7 books that are available. Now this being O'Reilly Media, I thought it would be fair to pitch my own book. So this is the Java EE 7 Essentials book, which I wrote for O'Reilly, which was released last year. It was actually the bestseller in the very first month itself. And today this book is 50% off, only for today, 50% off for the ebook and 40% off of the print edition. So if you want to buy it, go to shop.o'reilly.com, search for this book, Java EE 7 Essentials, and put it in your cart and buy it away. Now the entire source code, all the, the way I wrote that book is by writing a bunch of sample codes, and that's how I build these slides as well. So all of that information is available on this GitHub project. So if you go to github.com/Java EE samples, there are Java EE 7 samples/tests, which are written using Archillion. And there is a Java EE 7 hands-on lab that you can try it out as well. Now, one place, as I was saying, I would love to get your feedback and your involvement is these Java EE 7 unit tests, they run on Wildfly and GlassFish. And I can see that the number of tests have been constantly growing on both the platforms. There are different number of failures. We have a good handle on what those failures are on Wildfly, and we are working on those. But on GlassFish, there are quite a few failures. I'm not sure if there are test failures or there are problems with GlassFish itself, or because a lot of these tests were written after I moved over to Red Hat. So I would love your help if you want to try out any of these tests and send me a pull request. And once again, as I said, you can go to github.com/Java EE samples. It's an open source project. Look at any of the samples, tests. And from the github.com/Java EE samples, there's a link to the CI job, so you can take a look at that as well. Okay, I would like to conclude now. So if you want to learn about all the specifications, Java EE-spec.java.net provides all the details for different specifications. GlassFish, Oracle has killed the commercial support for GlassFish, so it's purely a reference implementation at this point of time. I would not recommend it for production deployment. On the other hand, Wildfly has a candidate release was released about a couple of weeks ago. It's a full-blown application server. You can start building your applications on GlassFish because JBoss EAP 7 will be based upon Wildfly, so you can at least start building your applications on Wildfly and then have them ported over to JBoss EAP 7 when it's released. And in terms of tooling, you have pretty extensive support for NetBeans, IntelliJ, Eclipse, all of those. And my blog, which is blog.arungupta.me, has details about all of these different tools. Okay, so that's pretty much the last thing I have. Let me see if I can go to the Q&A section.
All right, so we have a few questions here, Arun, and I'll just read them aloud. Let's see here. Rainer wants to know, is there a similarity with other development like C#? Is this only to be implemented with Java EE7?
So no, C# is a separate language altogether, and that kind of belongs in the Microsoft camp. So Java EE7 in that sense is purely a Java vendor thing, at least Java EE7. So what you would see is Java EE7 being implemented by Oracle in terms of GlassFish, and then Red Hat, of course, is doing it in Wildfly and JBoss EAP7, and you will see other vendors, for example, Tommy, and WebSphere and WebLogic catching up as well. So it's purely a Java thing at this point of time. I've not seen any Microsoft involvement in this, and I doubt I will.
All right. And Adam wants to know, what benefits do HTML5 forms bring to JavaServer Faces beyond what's already available?
Sure. So now JavaServer Faces, in that sense, integrates very well with HTML5 forms. I've particularly not played with them as such, but and one of the points that I mentioned early on about HTML5 is, for example, CSS3. And a lot of people ask me, how do I integrate CSS3 with JSF 2.2? Well, there is no additional work required to integrate CSS3 with JSF 2.2 or even HTML5 forms. All you will have to do is kind of continue working the way you're working, and just mark them as pass-through attributes, and the JSF will just pass it on back as is. And I think the other part people need to realize is Java EE7 provides a couple of programming models. So you can go server-centric programming model, where you take JSF approach, so JSF, EJB, JPA, all of that approach. Everything is done on the server side, or the other approach, which is sort of also called as a TSA or thin server architecture, wherein you have purely HTML5 forms, and then that being backended by a REST endpoint. So for example, you could have a JAX-RS endpoint, then that is doing your transactions and everything else, everything being exposed as a REST web service. So either of the combinations would work.
Excellent. Let's see here. Tim wants to know, you mentioned Eclipse for tooling. Do you know if Jetty supports NIO with Servlet 3.1?
So I believe Jetty is Servlet 3.1 compliant because they were part of the expert group. So yes, I think the answer is yes.
All right. And then Danny wants to know, how does EE7 compare to Spring Framework 3.x?
Oh gosh, there is no comparison. Java EE7 is way superior. Just kidding. Well, I was maintaining the Java EE7 brand at Oracle. I've written a book on Java EE7. So now Java EE7, if you realize the history, Spring was born because J2EE 1.2 and 1.3 were not done right. And that's the reason Spring was born, effectively. So in general, Spring community has shown a lot of hatred towards Java EE. But over the years, Java EE got its act together, and I think Java EE has really come to the point where it's starting to kick butts of Spring developers as well, in the sense that look at all the features that are coming, that are in there in Java EE 7 now. It's a pretty solid platform, and my approach, frankly, is I want to start with Java EE, or so let's say you're running your Spring application on a container. Now the container is Java EE7 container, likely, if it's not Tomcat. If it's Java E7 container, then, hey, I want to leverage all the capabilities that Java E7 already provides. So I would leverage all the capabilities of Java E7 runtime and then tap into anything else that is not provided by the runtime for a framework. Instead of saying, you know what, I'm going to ignore all the Java E7 capabilities, I'm going to build everything of my own by Spring. So that's how I typically see it. But having said that, this is the first time, like in past 15, 17 years, Spring kind of worked towards contributing towards JSR 352, which is a Java API for batch applications. So you'll see a lot of similarity between the two. Spring 4 was released late last year, and of the total 5 themes, there were 2 big themes were to be compliant with Java E7. And my point being, hey, you know what? What does it mean to be Spring to be compliant with Java E7? If you want to use Java E7, use a new Java E7 application server. Why would I go Spring route in that case? So I think both the routes are possible where you want to go with pure Spring and pure Java EE, and I think they will continue to exist. And it's sort of a church versus state battle. It'll always be there. I wish I could meet you sometime in a conference and have a discussion over beer on this.
And who knows, maybe that'll happen sometime.
Yeah.
And Karen wants to know, maybe you already had this URL. What's the URL for the hands-on lab? Was that the recent?
This is the github.com/javaee-samples. That is sort of the main project. So if you go to that URL, then from there I have the samples project linked. From there itself I have the hands-on lab project linked as well. Once again, github.com/javaee-samples. And we're looking for contributors. If you want to contribute, if you want to use it, by all means use it. But if you want to contribute, send us a pull request on anything.
All right, excellent. Parandeep Kumar has a question, and I don't know if I'm going to phrase this correctly, but I'll give it a shot. Modifications into annotations like @max(10) isn't a hard coding rather than a configuration?
Right. So, yes, I agree. What you're doing is, in your code itself, you're saying, okay, I don't want the quantity to exceed 10, but typically, you have that as an if block in your source code. So think about the method that I was showing in the bean validation slide. In there, I was saying, @not null and @max10. If you don't put it in there, typically you will have that as your if block saying, okay, if quantity is greater than 10, then reject the order or throw an exception. In this case, all you're doing is you're getting rid of that if block, putting it as just a constraint annotation, and then the constraint violation exception is automatically being thrown. So all you're doing is just improving making the code a lot more readable by looking at the annotation instead of relying upon a if block. So I don't think there is much of a difference in that sense, just better readable code.
All right, excellent. We have a few more questions here. David wants to know, and he says, sorry if you missed this, but when is EAP7 based on Wildfly expected to be available?
Yeah, JBoss EAP7 dates will be announced at Red Hat Summit this year, which is in April. So I would recommend, stay tuned for that.
All right. And then Mamadou wants to know how to contribute as a tester.
We would love to take contributions, Mamadou. So go to github.com/javaee-samples project. And in there, if you look at, specifically go to the Java EE7-samples project over there. And if you go there, then there we have a wiki. And the wiki exactly explains how the tests are written and what needs to be done. Look at the issues that are open. Try to close any of the issues. You can. There is a CI job running. So what folks are doing is they're checking out the workspace. They're saying, okay, I'm going to convert. See, originally these samples were written purely as samples. There were no tests for them. So one of the big tasks for me right now, and where I'm taking a lot of help, is converting these samples to tests. So what you do is you take a look at the sample. You convert it into a unit test or an integration test using Archillion, and just go that way. And there are issues open for different samples or different categories. There are wiki instructions which provide exactly how you can convert from a sample to a test. Any help is definitely welcome.
Fantastic. And last question here. Iris wants to know, if I wanted to sell my developers on using Java EE7, what would be your high-level pitch to get them on board?
I think the best way is to have them look at it. I'm more than happy to kind of work with you. You can reach to Audra or me directly. My Twitter ID is Arun Gupta. I'm more than happy to kind of give a workshop for you guys to show them the power of Java EE7, because most of the time it's not just purely a technical decision. You got to understand what your existing constraints are, what you want to do and how you want to do it, what your DevOps constraints are, what your cloud story is, what your in-premise story is, all of that. All of this would help, if you buy the Java EE7 Essentials book by O'Reilly Media. Just kidding, but yeah, I'm happy to work with you on this one-on-one.
Okay. And Parandeep Kumar actually has one last question here. And folks, if there was a question that you wanted to ask and weren't able to, then yes, you can always reach out to Arun via Twitter, and it's just at Arun Gupta that his handle is. So Parandeep Kumar asks, are there any automated scripts available to migrate from Java 4 to Java 7? Or do we
no. You mean Java? If you mean Java EE4 or J2E 1.4 to Java EE7, no. The programming model has changed drastically. And the fun thing is, if you're moving from J2E 1.4 to Java EE7, you will have to get rid of a lot of your code. So you'll pretty much have to kind of get rid of a lot of your deployment descriptors, get rid of a lot of your boilerplate code. A lot of that work would be gone. So there are no automated scripts, because there is a lot of valuable business logic that you guys have created that exists in there. So that needs to be carefully crafted and cleaned up. So this would be an effort. However, Red Hat Professional Services can help you do that. So if you are interested, then you can reach out to Red Hat Professional Services, and they'll be happy to assist you.
All right. Well, that concludes the questions and the webcast. Thank you so much for a fantastic presentation, Arun. It seemed well received by the audience, and we can't wait to do another one with you in the future. Is there anything you'd like to leave the audience before we leave today?
Yeah, with the last point, I think I mentioned this earlier. The book is 50% off ebook, 40% off print edition. So today is your opportunity. The book will always be available, but today you get a special discount. Help us spread the word on Java EE7. And Wildfly is almost ready to be released. Try it out. Perfect.
And we pushed out that code there. And actually, it's also the deal of the day as well. So you can use code DEAL if for some reason code WCYAS does not work. But it should. Anyway, thanks again, and we hope to see you all at future presentations, and have a good morning, evening, or even afternoon for wherever you're from. Thank you, Arun.
Thank you.
Goodbye.
Bye.